Tell us about yourself?
Yes. Good afternoon, sir. My name is Shah. I belong to a place called Bhandaro, which is in the Grade district of Jharkhand state. And my father is a farmer and my mother is a homemaker. I have done my schooling in Sainik School, Tilaiya, Jharkhand. After that, 1 year preparation of IITS, I got admission in the Birla Institute of Technology, Mesa, Ranchi, in the mechanical engineering in the year 2016, where I have done where I've done participated in various activities like a NCC, where I've got a BNC certificate from Ministry of Defence, Government of India. Also, I was participated in the 15th August in 2016, and after the college, I got placed in the Tata Power, and currently I am posted in the coastal Gujarat of Kutch,
Okay, so
MTBS, that is the Mundra
you are
Thermal Power Station.
great. So you are working in Tata Power,
Yes, sir.
and you are posted in their thermal power station.
Yes, sir. Mundra Thermal Power Station. Yes, sir.
Okay, great. So what's difference? I mean, core difference between a nuclear power station and thermal power, the conventional thermal power that like you work in.
Sir, in the Mundra thermal power station, we are having basically a coal-fired boiler where we are using a coals, basically the raw material that is being basically imported from the outside of the countries like South Africa or USA. And in the case of nuclear power plant, basically you're using uranium. These are as raw materials for the production of the electricity.
Okay, great. Which is the closest nuclear power plant for you, maybe?
So this, I think in the Mumbai region.
Mumbai has power plant, nuclear power plant. But do you think like we should have a nuclear power plant in a city like Mumbai?
No. Mumbai it is not there, sir. Rajasthan it is.
Yes, we have, I think, Rawat Bhata in Rajasthan, if I'm right. It's
Yes,
Rawat Bhata or Kakrapara. I think it's Rawat Bhata. Okay, fine. Point being, okay, so do you really think having a nuclear power plant in Mumbai is a good idea?
no, sir. Being the population wise, if you see that it has a lot of disadvantages according to that, sir.
Exactly, exactly. And like, as a someone who works in coal power plant, do you approve nuclear power plants?
Yes, sir.
Okay, great. So why do you want to join BRC, Akshay?
So actually, sir, BRC is a government sector. Actually, I also wanted to work in this sector. The reason being is that the biggest reason for joining the BRC is my family. As I've seen them how they were they were really working hard for the day and night for my education also. So it was their dreams to see me in the government sector as it's provided immense social status and dignity in the society, sir. And
Y-
being the BRC, it is one of the core sector of the mechanical engineering. So,
So you are joining to get status in your community? I mean, that's your prime
not
motivation?
basically, no, not basically that. It was actually my parents. They wanted to basically. They have seen in the society. Actually, they have wanted to me see in the government sector. So,
Okay, so you know, and Tata is as good as government, it is so called.
yes, it is. It is there, but the core that we are doing, the core basically in the field of mechanical research that being done in the BRC, it was quite.
Okay, great. That's amazing actually. So, what is the cycle that is used in power plant we have?
Modified Rankine cycle, sir.
Okay, and what's difference in modified and the plain Rankine cycle?
Basically, sir, the Rankine cycle that we are using basically it is on supercritical technology. There in which we are going above the critical point of the waters. Currently, we are having like a critical point of water like a 221 bar. So we are going above that, like a 251 bar we are reaching. And in that particular case, we are getting the work output that we are getting it much more higher than the subcritical boiler.
Okay, and why do we do that? I mean, what is the benefit of having supercritical or even critical boiler or critical Rankine cycle?
That is the efficiency of the boiler. So efficiency of the boiler in the case of supercritical is much more. Also, the latent heat that we are getting, latent heat in the case of supercritical boiler is zero. And in the case of subcritical boiler, it is had got certain it is there means latent heat. That's why, sir.
Correct. So why the heat input or no, here is a direct question. Why it has higher efficiency? Why a
Because
supercritical
the
Rankine
requirement,
cycle?
yes, sir. And the requirement of one of the region is the requirement of latent heat is zero in the case of subcritical boiler.
But you
Also,
still need
second
heat, right?
one,
You still need heat.
yes, sir.
From pump output to turbine input, we still need heat input.
Yes, sir.
I agree, it's not a latent
Uh,
one, but still you need heat input. So this is not a very concrete point. Yes, please go ahead.
one can I can say the circulation ratio. In the case of supercritical boiler, the circulation ratio is the one. And in the subcritical boiler, there is a means it can be ranged into 5 to 10 the circulation, where the heat is more added in the case of a subcritical boiler.
Okay, fine. What is efficiency of Carnot cycle?
It's 100, sir.
Carnot
It's
cycle has
much
100
higher.
efficiency.
It can reach up to the maximum efficiency.
It can. Okay, what is second law of thermodynamics?
So second law of thermodynamics, it is basically two parts. It is the Planck's Clausius etc. and the Planck's constant. Sorry, Planck's statement is there, sir.
Kelvin Planck.
Kelvin Planck's
Kelvin
law.
Planck. Yeah, what is okay, yeah. What is perpetual motion machine? Do you know?
Yes, it is of person machine of first.
Yeah, first kind.
So in this particular is state that whatever the work is being whatever the heat will be supplied will be directly converted into the work without any loss of energy.
Correct. Now, what is the efficiency of perpetual motion machine of this kind that you are talking about?
But it is not possible. So in that case, it will come out to be
Correct.
100%.
Correct. And you just said that Carnot cycle has 100% efficiency, right?
It can reach up to the maximum.
Is the maximum 100? Can you draw Carnot cycle for me?
Yes, sir.
This is what TS diagram, right?
Yes,
That arrow, is that going in or going out? Okay, it must be going in, I think.
it's
Yes, okay, good. Oh, can
it's
you,
supplied.
oh yes, it's applied. What is the efficiency of this now? You have a cycle,
Yes, sir. 1 minus TH by TL.
1 minus TH by TL, right? Can this be 100%?
Yes.
Okay, leave it. See, the second law itself states that, kind of it, that this is not the statement, but it essentially tells us that no cycle can have 100% efficiency. Okay.
Yeah, there must be some rejection.
Yes, some rejection. If there is rejection, that means it does not have 100% efficiency. Not even Carnot. So Carnot does not have 100% efficiency. You just, take a look at this. Why I'm grilling you
Okay,
on
sir.
this is because you already work in a power plant. Okay, so these are very expected question to you.
Yes.
Correct. So coming back to our main question, why modified Rankine has higher efficiency than Rankine cycle?
One thing that I have understood, sir, is in case of if you see the TS diagram, sir, in the case of as we are reaching to the maximum temperatures, more than the critical temperature, like 569 temperature range from highest point to the lowest point, it is much in the higher. That's why that will give the major output, sir.
Correct. So actually, the reason directly can be stated that the heat addition temperature is higher in modified Rankine cycle.
Yes,
Temperature
sir.
of heat addition. So, any cycle, the efficiency can be put as 1 minus temperature of heat addition upon upon temperature of heat rejection. Are you aware of that?
Yes. Yes, I think it can.
Yes. Now, in case of a, supercritical boiler, the mean temperature of heat addition is higher, much higher actually. That's why. Okay. Coming to a better question. Why do we have condenser in a power plant in a Rankine cycle? We are talking about plain basic Rankine cycle. Why do we have condenser?
For the heat rejection purpose.
Correct. Heat rejection purpose. You know, that's okay answer. So what I'll do is, I have turbine output,
Yes.
and I'll just let the turbine output go in the atmosphere. Can my cycle work?
Yes.
Can my system still work?
Yes, the system will still work, sir.
Correct. Then why do we have condenser?
So the reason being is that if we're using the condenser, sir, it has got a certain temperature. If you are taking the fresh water, then we require additional power to heat that water. But if you're using the condensed water, that it has got a certain temperature, we can utilize that temperature also. Rather than taking the fresh water, if you're taking the condensate water,
Okay. So, the fresh water will be at atmospheric temperature, right?
yes, sir.
Correct. Now it will be same as in condenser we use cooling water as well. Correct?
Yes, sir. Yes, sir.
Correct. Now it will be at the same temperature of atmosphere.
Cooling water, yes, sir.
Correct. Now the condenser temperature, it is less than the cooling water temperature or it is higher than the cooling water temperature.
It is higher than, sir.
Condenser temperature is higher than cooling water temperature.
Means the temperature that is coming out from the turbine, it is
Huh?
of higher and then the cooling water that we are supplying, sir, so that the heat transfer can occur.
In analysis out, right? Yes, correct, correct. So cooling water temperature is lower.
Yes, sir.
That's true. Now, here is a question for you. Let's say you are a power plant designer and you want to
Yes, sir.
manufacture or make a power plant, and you have given two locations. One is, let's say, your Kutch, and another location is Shimla.
Yes, sir.
Okay. Everything else is same. You don't need to worry about mountain, this, that. Okay. Everything is same. You don't need to worry about money cost. Where will you put the power plant?
Okay. If we see the in terms of the work output, sir, I think that in the case of a Simla, that it has got the lower temperature, so the work output from the turbine it will get maximum rather than in this area. Uh,
Why do we have a higher work output in Shimla?
because the lowest temperature in the Simla is much lower than the Kutch, sir.
And why does that matter? That's what I'm trying to ask. Your
Reason
answer
being
is
is that,
correct.
sir, if the reason being is that suppose we have two temperature and one is the suppose the TH higher temperature, one is the lower temperature. The more will be the difference, the higher will be the work output, sir.
You are giving correct explanation, but not to the point. It has to do something with condenser temperature.
Yes, sir.
Okay, see, so condenser is being cooled by cooling water.
Yes, sir.
Lower be the cooling water temperature, we can keep that low the condenser temperature. Make
Yes,
sense?
sir.
Okay,
Yes,
I'll
sir.
I'll just maybe draw it for you. How to I'll delete all this. Okay, how to delete? Eraser. Yeah, finally we have something. Yeah. Okay, see. So this is my TS diagram, something like this, right?
Yes. Yes, sir.
Yeah, the cooling water should lie somewhere here,
Yes, sir.
correct? Now for Kutch, this will be my cooling water temperature, but my Shimla cooling water temperature will be this,
Yes, sir.
right? So at Kutch, I will have to keep the condenser here, but at Shimla, Mekin, I can bring it down till here, right?
Yes, sir.
Yes, and essentially what you are doing is you are increasing the area under the curve,
Yes, sir.
despite having the same heat input. Heat input is from here to here, right?
Yes, sir.
Okay, so initially the graph is something like this. Now the graph is, extended a little below. So you are
Yes,
increasing
sir.
this much area. If you're increasing area, you're increasing efficiency.
Yes, sir.
Yeah, so that's why. Okay, so I'll conclude
Heat
your
rejection
inter.
risk will be the less in the.
Yes, heat rejection will be the less, and that's why higher will be the efficiency. Okay,
Yes.
Akshay. So uh, you have good knowledge actually about power plant. Today I ask you more about power plant because I can see it coming. That will be asked more to you. Okay. So overall, I'll say go through the power plant again. Cycles, I mean thermodynamics and power plant again.
Yes, sir.
Okay.
Yes, sir.
Go through that again because see, it will be asked. You are already in power plant, so I mean that's most probable one. Then you don't need to tell your 1 year gap that you had a gap
Okay,
of
sir.
1 year. Okay, leave that and change the motivation a little bit. I mean, it's a prestigious job and all, that is true. But keep that as one point and then have another as well. See, you already are working in a power plant. You can always say that, okay, you know what, I am already working in the energy sector, and essentially now I want to go into the renewable energy sector, and that's why I am aiming for BRC. That's such an amazing answer. Okay, there is no यहाँ पर कोई तुम्हें काट नहीं सकता इसको आंसर के लिए. ठीक है. So tell
Okay,
this
okay.
your answer.
Yes, sir.
Tell
Yes,
this
sir.
why BRC. That's an amazing answer that you are already working in power plant technology, energy sector, and now essentially you want to go
Yes.
into renewable sector. That's why you are aiming for BRC. Okay, great. Okay, everyone, Tushar, you,
Yes.
अरे दीप चला गया. ठीक है. So Tushar, you come on board.
Sir, there is one question.
Yeah,
I
please.
know.
Wait.
Sir,